today we are going to add and subtract rational expressions like this. Okay, these are just adding, we'll subtract later. But just to begin, I just want to review how we add just simple fractions. Okay, so there's a difference between these two. Do you see it? Besides, the numbers are different. Oh, you're right! Yes, this one, they have a common denominator. This one, they do not. So it's pretty easy to add when there's a common denominator. We got 1/6 plus 2/6, and we get 3/6. We don't change the denominator at all, okay? But you can reduce, right? So 3/6 is equal to 1/2. Okay, when we're looking at rational expressions, we also have to reduce if we can. Okay, so I'm just going to set this down for a moment and grab this board now. Okay, and if you look at this, is it glare or can you see it? Okay. All right, so if you look at this, they too have a common denominator. So all we have to do, we're going to keep that common denominator, x plus 1, and we're going to combine these. So we're essentially going 2x plus 1 plus x plus 2. Okay, so we're going to combine these. We've got 2x plus 1x, and that gives us 3x. And then we've got 1 plus 2, which is 3. So done, right? Nope, not quite. We can look at this. Remember when we were simplifying rational expressions? We would look to see if we could factor to see if we can cross stuff out, because crossing stuff out is always fun. So if you look here, there is a GCF. There's a GCF here, and it's 3. Okay, so then 3 times x is 3x. 3 times 1 is 3. Ooh, look at this denominator. What do you get to do? That's right, you get to cross them out. So our final answer is just a 3. Look at that. Sorry about the background noise. Okay, next, if we look at this problem, these do not have a common denominator, unfortunately. So we have to find one, okay? So, and I know you did this long ago, but just to review, because it's very similar to the other problem, 4 and 3, common denominator is? Yes, 12, I heard it. Okay, all right, so to get from 4 to 12, what do you have to multiply by? Yes, 3. 1 times 3 is 3. To get from 3 to 12, what do you have to multiply by? Oh, 4! Yes, we shall multiply by 4. So 2 times 4 is 8. Okay, 3/12 plus 8/12. I'm running out of space, but it is 11/12. And there's snow there, so it's hard for me to write. But that very clearly says 11/12, right? 11/12. There we go. 11/12. All right, so we're going to do the same thing with this problem. I mean, not really, but the same thing. Yeah. All right, so remember when we were simplifying rational expressions, you need to factor at least the denominator. We're going to factor the denominator here so that you can see what is missing in one of these denominators. Okay, so if you look at this denominator, do you remember what this thing's called? Yes, the difference of squares. All right, we reviewed that in a different video. X times x is the x squared. Remember, the insides and the outsides will cancel each other out, and to do that we have plus and minus, and then the square root of 9 is 3. So we have x plus 3 and x minus 3 for this denominator. Okay, it's actually not this anymore. It's x plus, I mean it still is, but we're looking at this, x plus 3 and x minus 3. Okay, here it's just x plus 3. It's kind of like we're looking at what the common, sorry, I'm getting distracted, what the common denominator is. Okay, and the common denominator here would actually be x plus 3 and x minus 3. Okay, because we already have an x plus 3 here. We don't have any extra things besides just an x plus 3 and an x minus 3. So we're going to go with the common denominator of x plus 3 and x minus 3 here. Okay, I mean, we already have it here, but this one, there's Legos on the other side of this. Okay, so in order to get this one to this, what do we have to multiply by? Because we already have the x plus 3. What do we have to multiply this thing by to get to x plus 3, x minus 3? Okay, so what we need to do, basically, essentially what we're doing is we're multiplying this whole thing by 1. Okay? But we're actually going to multiply the top part by x minus 3 and the bottom part by x minus 3. So do you see then that our denominator would be x plus 3 and x minus 3? All right, so what we're going to do, this one up here we already have the x plus 3 and the x minus 3, so we don't need to multiply this piece by anything. So we're just going to keep the 10x plus 12. Okay, and so I'm just going to write, and I'm just going to put this whole thing over x plus 3, x minus 3, just like that whole thing was over 12. Okay, so what I'm going to do is I'm just going to write this 10x plus 12. And over here, I'm multiplying by the x minus 3.
You wrote a 2.
I wrote a 2? I meant 12, sorry. Thank you, camera person. Okay, so over here, I'm going to multiply by my x minus 3. So I've got an x times x, which is x squared. Okay, and I'm going to erase this part so it doesn't confuse us. Okay, and then x times a negative 3 would be a minus 3x. All right, so I've got all this stuff, 10x plus 12 plus x squared minus 3x. Okay, so let's just combine this stuff. We've got x squared. I'm gonna write this in standard form. And then we've got 10x minus 3x. That's a 7x. And then we've got plus 12. Can you see that? It's pretty small. Okay, and then over x plus 3 and x minus 3. You guys with me? Okay, you would think we'd be finished, right?
Yes.
But unfortunately we're not. Okay, so if you look at this, we actually can factor this one. Okay, this is a trinomial that we can factor with 2 sets of parentheses. Okay, and what is the number that multiplies to be 12 that also adds up to be 7? Or what are the two numbers? Remember we did this little thingy? What two numbers multiply to be 12?
4 and 3.
Thank you. All right, so we're going to have x plus 4 and x plus 3 over x plus 3 and x minus 3. What do we get to do, guys? Yes, we get to cross stuff out. So then my final answer is going to be x plus 4 over x minus 3.
Can't you cancel the x's?
Ooh, that's a good question. Can we cancel the x's? No, when there's a plus sign or a minus sign between them, we cannot cancel the x's. They are separate terms. It's not like a unit. Like this whole thing we can cross out because there's parentheses around it, but we can't do that here. We can't cross out our x's and make it 4 over 3. Good question. All right. Are there any questions? All right, you guys are going to do great. See you soon. So, since it appears that we have subtracted all the snow, I figured we might as well work on subtraction. Does that sound good? Makes sense to me. All right, so if you look at this one, we have a common denominator. All right, so we're just going to keep the a plus 3, and then we need to go 5 minus 2 minus a. But we're not just going to write 5 minus 2 minus a. We're going to write 5 minus 2 minus a. Okay, do you see the difference? We need to now distribute this negative. So that becomes 5 minus 2 plus a over plus 3, which, look at this. This is like one of the most satisfying problems that we've seen. Look at this, 3 plus a over 2a plus 3. Isn't that the same thing? What happens? Oh my goodness. Boom, boom, gone. So if we cancel everything out, what does that become? Yes, it's 1. That's our answer. Okay, so our answer is 1 here. Excellent. All right, now if we look at this one is lovely, but it still has a common denominator, so that makes it kind of nice. Okay, but we'll need to factor it. Okay, so they have the same, it's the same denominator, okay, but we're gonna make it a factored denominator to see if in the end we get to cancel anything out. Okay, there is a number in front of the x, so, you know, that makes it really fun. Okay, so we've got 3x and x. That's the only possibility. Now we need to multiply to be a -2. So that means we're going to have either 2 and -1, or -2 and 1, or 1 and -2, or -1 and 2. What do you think? We need to end up with a -1 in the middle. I heard it. We're going to put the -1 here because then it multiplies with the 3 to give you -3. And then we're going to put the +2 here. Okay, and then we have -3 plus 2, which gives us a -1. All right, so now on the top we've got our 7x plus 5 minus a 4x plus 3. Okay, so then again, this negative is going to distribute here. So you actually get 7x plus 5 minus 4x minus 3 over plus stuff. Alright, so if we simplify this, we've got 3x plus 2. Okay, if we combine like terms. Over the 3x plus 2 and the x minus 1. Alright, and so this one's also, I think, equally as satisfying. Maybe not quite. Those cancel out. We get an x minus 1 in the denominator, and since there's nothing on top, we need to put a 1. So 1 over x minus 1. Beautiful problem. Beautiful. All right, and then the last problem for today is this one. And this one's a great problem too. However, if you look at the denominator, not so nice. Okay? We don't have a common denominator. Okay, so we need to find the least common denominator. And in this case, if there's 2 separate expressions like this, we just use them both. Okay, so we're going to use, we get d minus 1 and d plus 2. Okay, and remember when we were finding a common denominator when we were just using regular fractions? Okay, we looked to see what we had, to see what we needed to multiply by. Like for this one, this d minus 1, we have the d minus 1, but we don't have the d plus 2. So we're going to multiply the 3 by the d plus 2. All right? Because then we have the whole, it's like multiplying the top and bottom by d plus 2, because we multiply the bottom by d plus 2. Okay, we're already doing that, so we have to do the same thing to the top in order to be as if we're multiplying by just 1. Okay, and we're going to do the same thing over here. So minus 2, now we're going to multiply by d minus 1, because we already have the d plus 2. So to get this in the denominator, we had to multiply the denominator by d minus 1. So we also need to multiply the numerator by d minus 1. Okay, so this actually isn't so bad now. Okay, pardon my handwriting. I'm multitasking and it's not as easy as it seems like it should be. So 3d plus 6 over here minus 2 times d plus 2. Notice I caught myself there. Over the d minus 1 and d plus 2. All right, now I'm going to combine my like terms. And I fear that I'm going to run out of space. But we've got, I think we might be okay. So we've got 3d minus 2 times d, which is just plain d, and then plus 8 over the d minus 1 and d plus 2. Okay? There's not anything to cross out, so it's good sometimes to just make sure that we didn't make a mistake. Okay, because, you know, it's nice for these to be nice for them to be satisfying. So let's just make sure 3d plus 6 minus 2d plus 2. I mean, oh, there, I did it. Okay, so sometimes it's not always satisfying in the end. You don't always get to cross things out, but it is a good idea to check because generally you do get to cross things out. All right, so we're all done crossing things out in this chapter. Okay, we've basically finished chapter 11. Fantastic. All right, good job, you guys.
And even though the weather is constantly changing in Nebraska, it's always perfect weather to do some math.